talk. I'm going to tell you about the .NET API. It's aimed at beginners to help you understand the way the API is set up and help you get started to develop things with .NET for FHIR. After this, of course, you can also go to more specific training sessions telling you about validations and things like that, or creating your own FHIR server. But hopefully you can learn something, and hopefully afterwards you will join the hands-on tables for a tutorial where you can do exercises and ask any questions you still have after this talk. I am Mirjam. I work for FHIR, so I'm part of the FHIR FHIR team, but you have already seen my shirt probably. My contact details are on this slide. Feel free to email me afterwards, even after the DevDays as well. If you have any more questions left, you can always drop me a line. And if it's just to say, okay, I've developed something really nice, take a look at it, I'm happy to do that as well. And hopefully you'll get in touch, and this is one of the first ways to get in touch with the FHIR community, of course. We're going to take a look at the FHIR API, and if you will see my slides, you will find lines with a blue star in front of them. And if you get the presentations later on, you can copy-paste those lines to have some example code. So we're going to look at the HL7.FHIR package that has been created mainly by Ewout, but also other people have contributed to. If you are going to use it in your Visual Studio, go to the NuGet package manager and you download the STO3 package if you are going to develop the current version of FHIR. Of course, there's also older versions, so if you still need to develop things for DSTU2, you can use that as well. And some of the syntax might be a bit different for that version, but the main idea will be the same as I explained in this talk. So what will you get if you use this package? You get the model of FHIR, so all of the resource and data types are inside. There's REST functionality to set you up with a FHIR client and easily send your requests to a server. There's also parsers and serializers and other helper functions. And as I said earlier, you also have... Oh, do I need a microphone? Okay, thanks. So I'm probably not... Is this better? Okay, thanks. Other helper functions you have as well in the API, and Ewout will be talking about validation because there's a whole complete set of validation methods as well. The source is on GitHub as well. If you don't want to take the NuGet package, you can take a look at GitHub and find the things there. So the first thing we're going to take a look at is the model. Using statement you put on top, of course, and then, sidestep to FHIR itself. This is a screenshot from the FHIR website. For each resource, as you've probably heard from Richard earlier or have experienced yourself already, for each resource you have the specific definition for that resource on the website of the FHIR specification. So you can look up all of the fields that are available and the cardinality of those fields as well. These things are used to create the model in the FHIR API. So for each of those resource and data types, you will find a partial class with the name of that resource or data type. And in this case, it's the observation class because I had it in my slide. And it's of type domain resource. It's a partial class because then you can also implement your own code. So you'll just have to set up another partial class called observation and put your own code inside if you need code to be executed every time that you use observations. So in the observation resource, we have a field called status. And the status you can see is 1-to-1 and it's of type code. In this case, this is a field that is bound to a specific value set. And as you can see from the definition, that value set is a required one, which means that you can only use the codes in that value set. If you encounter those kind of fields that have a required value set, then for this value set there will be an enumeration inside of the model of the API. So in this case for observation status, I can find that there's an enumeration and I can use that to fill in the field with the correct value. So these are my example codes where I create a new observation and then I fill in the status with a status of preliminary. But because it's an enumeration, I know that I will never be able to put in the wrong value that is not inside of the value set. So that helps you already a little bit. Another field is code, and I said just now with the status as well, it has got a data type. In this case, the type is codable concept. So also for all the data types, you will find a class, and in this case you can see that my code field in my observation is a codable concept, a public codable concept. I can fill that in by creating a new codable concept, the type, and there are some constructor methods available for you. You can just create a new codable concept without them as well, of course, it's an overloaded method. But in this case, I fill it in, and I don't know if you are familiar with the structure of a codable concept. Who is not familiar with the structure of a codable concept? Okay. A codable concept is a coding data type, and it consists of 0 to star codings. A coding can take a system and a code and a display value. And in a codable concept, that means that you can have multiple codings inside with a system, a code, and a display. In this case, my constructor makes sure that one coding inside of this codable concept is constructed, and it takes the system and the system as first value, and for the code it takes the second value, and it sets the main display text for the codable concept to this example code. So it helps you where you don't have to create the underlying coding data type. It will just help you fill in one for you as well. If you need multiple codings inside of this codable concept, then you'll have to construct another coding and add that to this codable concept. I was talking about these lists. Lots of things in FHIR are 0 to star. In those cases, you will see, well, in this case it's the identifier, you will see lists in the model of the API. So in this case, I have a public list of type identifier called identifier for the identifier field of the observation. And I can use things like the add, this is just a normal .NET construction, the add to add a new identifier. And again, I have used one of the overloaded constructor methods where I can just fill in the identifier namespace and the identifier value. But you could first construct a new identifier, fill in the values by hand if you need or want. I like to make it easier and put it in one line, so I have created a new identifier and put it on my observation. Of course, I can add multiple because the specification says it's 0 to star. Did anyone explain you about choice properties? Who doesn't know about choice properties? Okay. Yeah, you're a beginner group, so that's all right with me. In the specification, you will find this construct in multiple resource types. So for observation, we have this value X part. The X means you make a choice in data type. And if you look at the definition of my observation, this is not a complete list, but a subset of it. You can see that you can fill in quantity, you can fill in a string, you can even fill in a range that's falling just out of my picture. You can fill in multiple data types for this specific field, the value field in observation. That's called a choice property. Because the API doesn't know beforehand what kind of type you are going to fill in that field, you will see that these choice property fields will be of type element. And Richard in the other room explained that all data types in FHIR derive from the main type element. So you can see that back in the API as well. What this also means is that you will have to first create a FHIR type, and then you'll be able to fill it in inside of this value. So for example, I can create a new quantity, fill in some values for the quantity, and then I can set the observation value to that quantity. I could also have chosen a string. I create a new FHIR string and put that inside of my observation value. So you first make the choice, create that FHIR data type, fill it in with the value you want, and then you can fill in the field inside of your resource. In the resource definitions, you will also encounter these extra parts in a sub-tree inside of the main tree. In this case, it's the reference range part of the observation. We also call this a component. And you can see that name in the side of the API as well. So for observation, we also have a public partial class reference range component. This is part of the observation namespace, and it's of type backbone element. Everywhere where you can see this backbone element inside of the specification, you know it's a component, a block of information within the bigger resource you have. So if I want to fill in reference information for my observation, I will create a reference range component, and you can see it inside of the observation namespace. I can fill in the values afterwards according to the definition you have, all of the fields you have information for, and then I can add this to my observation. And as you can see, observation reference range is 0 to star again, so that's why I use this add construction to add it to the list of observation reference range components.
Are the list already initialized already?
Yes. So you don't have to do that. You can just add to it. And that's one of the things. Good question. Yeah. Okay, so going to the patient resource for this example, we have primitive data types and non-primitive data types. In FHIR as well, primitive data types, Boolean, string, etc., you all know about them. And the other data types are the complex data types where you have multiple fields within those. But if we are going to look at this one, we have the active is of type Boolean. It looks really normal, and it is, look at that, this is inside of the definition of the patient class. We have the field called active, and it's of type bool. And I can fill it in like this, create a new patient, and set this field to just the normal Boolean value you would expect. But primitives in FHIR are not really primitive. We also have this active element. It's the same internal value. So we have this active element, and you can see it's of type FHIR Boolean. And I can fill it in with this construction where I create a new FHIR Boolean, set that to the Boolean value I wanted, and fill in this active element. Everywhere where you have a field that is of a primitive type, you will see in the API the double notation, the normal field where you can fill in the type as you would expect, and the one with a name and element attached to it. Why would we do that? We have a name of type human name. I'm going to create that. And within the human name, you can see that there's a given bit inside. It's name.given. It's again a list because it's a 0 to star in the FHIR definition, and I can fill that in two ways. So I could do a name.given, create a new string array, and fill it in with a name or multiple names if you have multiple, or I could use the given element construction where I can add to it, but then I will need a new FHIR string. Also for the family, it's the normal data type you would expect. You can fill in a string, but you can also have the family element, of course. The reason to have this construction is that there are extensions in FHIR. Have you all heard about extensions? Who doesn't know about extensions? Ah, good, no hands this time. So this is just like I can skip them. That's the way to view an extension inside of the XML. You can fill it in JSON as well. You cannot add an extension to the normal .NET data type. You cannot add an extension just to a string or just to a Boolean. And that's why we need the FHIR data type as well, the FHIR string, the FHIR Boolean. In the Netherlands, we would like to break apart the names. That's a really nice thing we want, where we have extra bits in front of the name, or in this case, my name consists of 2 names. And I could create an extension, but I need to have the family element part, because I can't extend family. That's a simple string. Family element gives me the opportunity to add extensions to it. And in this case, what I've done is I have indicated with the Dutch defined extension for the partner name that my partner's name is in fact the first part of the name I normally use. So wherever you need to do extra things, you will need to take a look at this element part, and then you can add to lists, add extensions and things like that. If you're just happy with filling in the normal string, that's fine, but know about this, that if you need extensions, then you can do it with this construction. Any questions so far?
About the extensions, are they handled like, I guess you have to specify the resource definition if you do an extension to a resource. Is it done by inheriting or done by the partial class that you generate?
Well, the definition is defined in a FHIR resource, and the construction is just like this. Every part in FHIR has this extension part inside, so you have patient.extension, you have patient.name.extension and things like that. So that's taken care of for you already. But if there's some extra part that you need to be, some code you need to be executed whenever you get a patient or create a patient, then you would put that inside of your partial class on patient, or on the data type that always needs to have that extra code executed. But you will always see this construction with the dot extension. So the dot extension is provided to you already by the model of the API. Yeah? Okay, so now you know about the model, and well, I invite you to try it out later on to create some instances. If you are going to implement your own server, you use the model as well, of course, but the next part, the RESTful part, I will be talking more client-side. That doesn't mean that you cannot use all of those methods in your server or your other program if you are not a real client per se. There's a list of available FHIR servers you can test against. And it's on the link that will be provided in my presentation, and you will get the presentation, or you can ask me if you need it earlier as well, and I'll put it on a USB stick. So what I'm going to do is going to create a new FHIR client. I will set it to one of the test servers, and in this case it's our own Vonk server for FHIR. And then I can set some options if I would want. You don't need to. Of course, some of the options will be the default option anyway. But in this case, I've just said, okay, I want to have the XML returned to me. If it's important to you that you get XML back, you could set the client to that already before you perform any communication with a server. And I can also set the prefer header, the preferred return by, for instance, saying, okay, I want the representation, I want a complete resource return back to me from the server. You can also ask for just an operation outcome from when things go wrong, or a minimal that you will just get the location sent back to you. The client can then be used to perform Crud operations. So in this case, the example is for the create operation. I've created a new observation from the earlier parts in my presentation, and then I can fill in other mandatory fields and fields you have data for. And then I want to send this observation to one of the test servers. So it's just a matter of sending or using the create method to send your observation to the server. And since I've set the base URL already in the previous example for my client, this client will know where to send it to. And it will know exactly the correct HTTP headers it has to send to the server, things like that. So you don't need to know about them. You can just use this method, and the lower level details will be handled by the API. And of course, this can generate an error. For instance, if you have done something wrong in your observation still, or the server cannot accept your request. So I would advise to add some error handling around this. I have not done that in my examples, but you will do that in your real programs. So that was the create, and we can also do a read by using the read method. We can change some data and use update to send the patient back again after I've updated data, and delete. Well, it's just what you would expect. The names take these forms. And for the deletion, you can use an in-memory object like the patient I have, or you can specify the ID for the patient or the resource you have, and then the server will try to do that. Yeah.
Only use ID or also the identifier?
If you use the identifier, you can, but then it's a conditional delete. And then you will have to supply the correct conditional syntax to look. Well, it's actually a search then on this identifier, and then it will be deleted if it exists. Or perhaps if there are multiple with the same identifier, you will get an error back. But it can be done, but then it's not called a real delete, but it's called a conditional delete. But of course, you can do that with the API as well.
This URL patient is case sensitive?
Yes. Yes, it's case sensitive. Yeah. So you will always see that the name of the resource type is with a capital beginning letter. And then after the slash, it's also case sensitive as well.
Is there any reason why it's case sensitive?
What?
Why it's case sensitive? Like, is there any specific reason? Because it's like URL, right?
Yes, but it's also. Yeah, the question is, why is it case sensitive? Because it's just a URL. That's because they have followed the RESTful mechanism of looking at servers and creating requests, and that's specified in the specification, in the FHIR specification, that it is case sensitive. Yeah. Okay. If you need, you can also look at the request or do things with the request before you send it out, and do things with the response after you get it back. So for example, if you need to add extra headers, if you are going to use Smart on FHIR, perhaps you need some authentication headers, you can put them in by putting this in the onBeforeRequest event. So you add an extra event handler to it, and in this case I have just added some key and some value, but you would add your authentication key and values inside of this, and that will make the client first put this in your request and then send it out. And afterwards, if you want to look at the raw response, for instance, you can look at the after response event and then well, catch whatever is inside that you cannot catch later on anymore, I cannot view later on anymore. So you can use these extras if you need them. In the RESTful part of the specification is also the possibility for searching. So what we have here is a search params class where you can fill in search parameters, And you can do that in several ways, but in this case I've used the fluent notation, where I can fill in a where clause with a name and value pairs. Do you all know where to find the specific search parameters for the resource types? Who doesn't know this? Okay. If you look at the FHIR specification website and you go to one of the resource type pages, so for instance look up the patient, you scroll all the way down, and at the bottom of each page you will see the list of search parameters that are possible for that resource type. Those are the standardly defined search parameters, so in your use case you could have custom defined search parameters added to that, but there's a standardly defined list and you can find that on the definition of the page. So one of the things for patient I know is the name search parameter. And if you look at the table in patient in the definition, you will see that it will look at the family names and the given names. But there are also lots of other possibilities. So please take a look at the bottom of each resource type page for the specific search parameters you can use. I've just said it, I'm going to look for Ewout. Did you see the video this morning? You know I'm a big fan of Ewout. Okay, so I can also include information. There's also a search page on the specification website where you can view the low-level syntax and view what it would look like if you would type it in by hand and put it in the URL yourself. But with this construction, the API handles those low-level details again for you. So I can include extra information, the organization that this patient points to, for instance. I can limit the number of search results. I can ask for just a summary if I want. I can order by a specific field that's in a specific search parameter actually, and fill in the sort order as well. Whatever you need, you can fill in these search parameter details. If I filled it in somewhere and I need to add extras later on, I can also, of course, use the add to add extra name and value pairs like this. After I've set up my search parameters the correct way, I can perform a search on my client.search, and I supply it with this search parameter, and then we'll send back a bundle of results to me. So that's why I have put them in a result bundle. Yeah.
You repeat the include again. Do you get the organization resource together with the patient, or?
Okay, yeah. So the include means that within patient we have a link to another resource type called organization, and if there is this link, if it's available for the patient and the server can retrieve it, the organization resource will be included in the search results. Yes. So normally if you don't do any include or reverse include, you will just get back patient resources with my search, but if you do include or reverse include information, then this bundle will be a mix of patient resources and the included types that you have added to your search parameters.
Does this also work for observations then? Include?
Yes, it's just the same way for observations as well. If an observation has an outgoing link to another resource type, we call it an include if you want to have that extra information added to your search result. It's a reverse include to have, for instance, well, observations can point to patients, and I can reverse include all the observations for this patient. Then I get the observations pointing to this patient with the result as well. Yeah. But this method can be done for all of the resource types, as long as you know which are the outgoing links and the incoming links, then you can include them. And that can be seen in the search parameter table at the bottom as well, because it will be of a type reference, and you'll know that it's a reference to an outside resource type. Yes? Okay. Yeah.
Does that also support like designation?
Yes, that's this slide. Actually, the question is, do we support pagination? Yes, because in my search parameters I can limit the number of search results sent back to me, but also servers will have a limit, usually not sending you back thousands of results if they have them. They will send the first page of results, and then with this construction I can look through the specific parts, because in the bundle there will be a link for pagination, and with this continue method I can take my current bundle and set the page direction. The API will know where to look inside of the bundle to take out the URL that retrieves the next page, in this case next, but you can also first, last, etc. And it will retrieve the result I asked for. So in this case I'm paging forward through the results to get the next ones and then do something inside of my loop. Of course you do not need to have a loop per se, but you can also create buttons in your program that take this page direction and ask the client to continue in the direction that you want. So there's other helper functionalities. For instance, for the resource identity, I have this identity, resource identity class where I can do things like see if this identity from the resource has a base URI or has a version attached to it, and I can also take the resource type from it. And this can help you construct resource identities or view resource identities and make decisions upon that. So this, for example, is a new identity I create with some extra bits inside, and I will get a good FHIR resource identity constructed with this example. I can also take an OID and create a FHIR resource identity with this. But usually you can take out stuff as well by looking at the base URI or resource type. And this is not a complete list you can take out with resource identity. So play around with that if you are going to try the exercise later on. We also have transaction builder functionality. You can create a transaction bundle to be sent to a server, or a transaction response when you are a server and need to send back a response. And then you can use the transaction builder functionality where I can fill in the create entry inside of the bundle, or a history entry, a delete or a read entry. And the API will take care of the details inside of the entry request bit of the bundle for the transaction. It will be a transaction builder object. I added some things afterwards as well, after I had done the first bit.
I'm sorry.
Yeah.
Sorry. Is it like a function chaining?
Yes.
So how does it work? Does it work like JavaScript? Executed one after another?
Yes, it will create a transaction bundle or transaction information actually, where it will set an entry to a create, then set another entry on that same transaction for a history request and things like that. But you can also do it like this, that we have the transaction builder and fill transaction builder with actions separately. It's just a matter of what your preference is, how you program. Can be done multiple ways.
Is it executed in sequence or simultaneously?
No, it will create a transaction builder in memory, and then I can convert that to a FHIR bundle. If I want to send this transaction to a server, I will have to create a bundle first. That's with this method, and then I can send that with the transaction method to the server. The server will then know it will receive a transaction and will then be able to read the bundle, which is just a FHIR bundle constructed through the transaction methods with the transaction things inside. It will just help you, because if you need to create the bundle by hand, you will need to know what to fill in exactly, and these extra methods will do that for you. So it will always construct a good transaction bundle where you could perhaps forget things inside of, or use a wrong syntax. So this will help you, and you will not have to fill in all of the fields by hand in your code. You don't need to use this. You can just create a new bundle and fill in all of the fields by hand if you want.
In your example, how can I bind a patient to an observation when I update the FHIR server, for example?
If you have do you
I have
have
an
a new
observation and I want to bind a patient identification.
Yes, so you have an observation, you want to bind a patient to it. Are they both non-existent on your server, new ones, or is one of them already on the server itself?
I don't know.
Okay, can be two ways. So if you have a patient on your server already, and you create an observation and you want to point that to the patient, then you would have the observation.subject field, which is a field of type reference. It's a reference. So it's just a URL you can fill in. So you need to know the identity of the patient on the server, and you can fill that in the observation.subject field. That's the way to link it. That's why I asked, does your patient exist on the server already? Because if it doesn't exist, it doesn't have an identity yet. And then you could use a transaction, and you can use an earn UUID construct to create a temporary identifier. In your observation, you link with the temporary identifier to your patient, and you set that ID on the patient as well. You put both the patient and the observation in your transaction, and send the transaction to the server to be created. Then, if everything is correct, both the patient and the observation will be created, will get a real ID, and the result, of course, will be sent back to you. Does that answer the question? Yeah? Okay.
So let's say I have a profile, okay, and I have few extensions there, and I have written this for my Java server, okay, and now I have a .NET client. So, and I have to read the extension, those values. So my question is like, from the profile, can we create the like typed classes? Like what is the best way to read the extension?
Well, the model will always be. Oh, repeat the question. Yeah. So you have a Java server where you have profiles and few extensions in the profiles.
.NET client.
Yes.
Okay.
So you're building a .NET client and you want to be able to read the extension.
So I mean, can we have a client in the typed client? I mean, where like class.property instead of reading the extension and then values.
Well, the way you get the information sent to you will always be a JSON or an XML format. And there will always just be this extension value construction inside of it.
But for that, like, I have to give the, I mean, let's say there are 10 extensions, right?
Yes.
So for reading every value, I have to give the name. So I am asking, like, can we have a typed value? I mean, where, you know, strong type, right? So can we read it that way?
I think we should, we will try at the tables to see what you need, but the extension construction is in the API, so it's in the model. And the way you get it sent to you, the JSON or the XML, will just have a list of extension bits inside. So if you parse that into your object, you will just get a list of extensions inside. For instance, if you have patient.extensions filled in and then 10 extensions, it will just be a list of patient.extension 10 times. Yeah? Okay. Any other questions?
I have a question.
Yes.
So, at the beginning of the slide, you mentioned some complex type can be a region specific. Also, suppose for instance, name. In some regions, there can be three names for a person.
Okay. So the question is, I have perhaps we have complex data types, which are in the model, of course, and you will have extra. Perhaps a profile because you have extra additions to the name or extra needs for the name, then you would have a profile on your system.
My question is, is it, do we have an option to add a region there? I mean, suppose for the Netherlands you have a different way of writing the name.
Yes, the option to add extras to a normal data type is to add extensions to that data type. Then you will still be able to use, for instance, human name data type, and with your extension, because everything in FHIR can be extended. So you would create a name, and then you will have the .extension bit filled in with your regional extra information.
Is it a global thing? I mean, if I fill in something for my region, who will confirm that it's the right fit?
If you still hold to the way FHIR is being set up with the extension bit inside, and not create extra fields with your own names, then you're still FHIR compliant. So you will need to use the extension construction to add extra data to your resources. And then you will always be FHIR compliant, and another system can read it, because we all know about extensions. The API will make sure that it can be parsed inside of the in-memory object, because you use the normal construction for extensions. As long as you do that, you're fine. If you say, okay, I'm going to invent my own names for certain things, I will invent a field called region inside of a human name, or an address, or then you break your interoperability with others, because then you're not FHIR compliant anymore.
And I'll ask one more question. It may be irrelevant to this topic, but how do we store images in FHIR?
There's the attachment data type, and you can also store them as binary resource. But if you need that, we can go afterwards and see how it's done in the FHIR API. So I invite you to later on today, after the tutorials, go to one of the tables. There are 2 tables with a green sign on them saying developers track. I will be there, so if you have any more questions, I will be able to answer them there. And I hope you are going to create some nice code and have fun and connect with others. Thank you for your attention.